Hi, I'm Wayne Lack and I'm doing January 2013 Core 3 past paper for AQA. We're now on to question 4. So the examiner's report says that in part A, nearly everyone gained the method mark and most people then gained the accuracy mark. So that's good, we'll get onto that in a minute. In part B, quite a lot of students got it, but a small proportion got a little bit mixed up. So we'll look at that one in a bit more detail than A. So let's turn to the whiteboard and do question 4. So question 4, the diagram shows y equals f of x. We don't know what f of x looks like, we don't know what f of x is, but we know what it looks like. It looks like this. Part A says sketch y equals mod of f of x below. And obviously in your exam paper you would have an actual thing drawn for you, an actual axis. I'm going to draw it here on the whiteboard, but in your exam you would have it neatly there ready for you to draw. So the mod is for the entirety of f of x, so it's how you know the modulus to be. There's nothing tricky going on. It does not go below the x-axis. So it would go down like this, normal, but then this underneath curve would then bounce back up. It would be reflected. This part would still curve, but it would then go up rather than down. So that's the method mark that I was talking about. Most people gained this mark, but for accuracy you need to understand that this point 4 and this point 0, they haven't changed, they haven't moved across. It just, rather than going down at the point 4, it went up. So it's a good indication that you know what you're doing if you put the points on as well. They also want to see some curvature here, because here it goes down, then it's quite a sharp point upwards, quite a sharp change of direction. But here there's quite a nice curve, because there's quite a nice curve here and the entire thing is reflected. So there'd be a quite nice curve here. So they like to see curvature. So that was worth 2 marks. Part B, describe 2 geometrical transformations to map y equals f of x onto y equals f of 2x minus 1. So we know that there's a translation and a stretch there, hopefully, because of this x minus 1, there's a translation, and because of the 2 in front of the x, there is a stretch. So there was sort of 2 answers available here. You could say a translation by vector and then put the vector in, so it's 1 on the top and 0 on the bottom, rather than minus 1. And then after that it's a stretch, scale factor, SF stands for scale factor in this, scale factor a half, not 2, a half in the x direction. So they want to see the translation being right. You don't put a minus 1 there, the 1 has to be on top as well. Stretch is a mark, scale factor half is a mark, and in the x direction or x-axis is a mark. What you could have done is you could have done the stretch first, and if you'd have done the stretch first, then it would have been by vector 0.50. It would have been the opposite. No, it would have been a half compared to if you do it the other way around. Because this translation is in the x direction and the stretch is also in the x direction, they affect each other, and so the order that you do them actually makes a difference. So if you do a translation first, then you're just translating it, so it would be 1, 0. And if you translate it, the scale factor that you stretch it isn't going to be affected by a translation, so it's stretched scale factor a half. But if you stretched it first by the scale factor of a half, then the translation is then affected in order to get it to the same point. So that's where a bit of confusion came in. Most people did it right. They said they figured if you put a translation first, then that isn't going to affect the stretch, so it's what you'd expect. But a few people did put the stretch first, then put 1, 0, which is wrong. So if the stretch is first, it has to be 0.50. And this was worth 4 marks. And like I said, this one was worth 2. And this is extremely common in Core 3 papers. The 2 geometrical transformations on something is extremely common, and it's always 4 marks. There's always a stretch in something else for 4 marks. And having to sketch graphs with modulus things is extremely common for this type of modulus. There's also f of mod x, which is a bit more rare, and that's in a different paper that I've done, so if you can check that out if you get to it. But this kind of modulus, where the whole of f of x is in the modulus sign, is extremely common. That comes up quite a lot. So altogether this was 6 marks. This was question 4. I hope this helped. I'll see you at question 5.